Okay guys, welcome to this video looking at use function machines, okay, and it's from the White Rose Maths, okay, yeah, so it's a White Rose Maths PowerPoint, okay, looking at GCSE Maths, okay, particularly for the higher tier and foundation tier, but this is predominantly for higher tier students for GCSE Maths, okay, looking at grade 5/6 here, if not above. Okay, so this is also appropriate for year 10 students and even year 9 students as well, okay, and even AS pure math students as well, okay. Get ready, okay, White Rose Math. Okay, so this is our starter, guys. This is question number 1. Complete the expressions without using an operation. Part A, y times 4. Well, that simplifies to 4y, okay? In maths, we write the number and letter without a times sign, okay? That denotes that I'm doing 4 times y, or 4 lots of y, or y times 4. For part B, y times y, that will be equal to y squared, okay? So you write it as y to the power of 2, okay? If it's y plus y, then it's 2y. If it's y times y, then it's y squared. Okay, if you multiply, then it's written as a power or an exponent or an index. For part C, y times 4 times y. Well, y times y is y squared. Times that by 4 and you get 4y squared. Okay, so you get 4y squared. Okay, we always write the numbers first and then the letters follow afterwards. Okay, so that's just the process that mathematicians use. Okay, for part D, 4 times y times 4. I do 4 times 4, which is 16. 16 times y is 16y. Okay, without the times sign. Okay. So in algebra, we don't write a times sign when we have a letter times a number, okay? It is like an invisible times sign there, okay? Question number 2, expand and simplify part A. So x minus 4 all squared, so it's going to be like a double bracket. So x minus 4 times x minus 4. Okay, so expanding it, a double bracket here. So using the method of FOIL, okay, or any other method, okay, I'm going to do x times x, which is going to be x squared, okay. Then I'm going to do x times negative 4, which is going to be minus 4x. Then I'm going to do minus 4 times x, which goes to minus 4x again. And then I do minus 4 times minus 4, which is going to be plus 16, okay. So again, obviously taking our time with this, okay. So everything in the first bracket is being multiplied by everything in the second bracket. Okay, and negative 4 times negative 4, remember, a minus times a minus gives me a positive as a sign, gives me a plus as a sign. So positive 16 or plus 16. Okay, simplifying it by collecting like terms, I'm going to have x squared subtract 8x plus 16, okay, because minus 4x subtract 4x simplifies to minus 8x or negative 8x, and we've got the plus 16 at the end, guys. Okay, sorry about my handwriting here, I apologize here. Okay, that one there. Okay, so that's that is obviously going to be part A. Okay, so let's just obviously delete that now that we've obviously worked it out. Okay, for that one there. Okay, so that's the answer for part A. For part B, again, expand and simplify, 3y minus 4 all squared. So again, remember, if you're squaring it, you're timesing it by itself. Okay, so it's a double bracket, okay? Because a common misconception is that students would like write down, for this, for example, they would obviously write down 9y squared plus 16, which is partly true, but then obviously it misses out like a middle term. Okay, remember, if you square everything within a bracket, then everything inside the bracket is being times by everything in the other bracket, okay? Subsequently, okay, using FOIL. Okay, so let's just obviously delete that here. Now we've got an answer for that. So the answer for this, if you're not sure, is x squared subtract 8x add 16. Okay, for that. For part B, again expanding it, 3y times 3y, remember that'll give me 9y squared. 3 times 3 is 9, and y times y is y squared and not 2y, okay, so be very careful there. 3y times minus 4 is minus 12y, and then negative 4y times 3y is going to be negative 12y again. And then negative 4 times negative 4 is positive 16. Okay, remember that a negative times a negative makes a positive as a sign. Okay, simplifying it by collecting like terms, I'm going to get 9y squared minus 12y goes to minus 24y. So I can just delete this here. Okay, so it's 9y squared here minus 24y. And then it's going to be plus 16, okay? And that'll be your final answer for part B. Okay, question number 3a, factorize x squared plus 2x plus 1. So factorize a quadratic expression. Okay, here it's going to be like a double bracket, okay, if you're not too sure. Okay, so x squared is made by doing x times x. Okay, sorry about my handwriting this today, guys. I apologize. Yeah, if I'm talking a bit faster, then yeah, I'm actually writing down issues here. So forgive me for that. Okay, sorry about that. So two numbers that add to make positive 2 and times to make 1. That'll be plus 1 and plus 1. Because positive 1 times positive 1 is going to be positive 1. And positive 1 add 1 is positive 2. Okay, now I can write this as x plus 1 all squared. Okay, because essentially you obviously times something here by itself here, okay, and this is obviously quite important here for when we look at function machines today, functions. For part B, factorizing this, that's going to be x minus 6 times x minus 6, okay. Oops, sorry about this. Okay. So x minus 6 times x minus 6, and again, yeah, if you're unsure, yeah, you are able to double check by expanding it. So obviously x and x make the x squared, okay. Two numbers that add to give me negative 12 and then times to make positive 36. That'll be negative 6 and negative 6, because negative 6 add negative 6 is negative 12, okay, and negative 6 times negative 6 is positive 36, guys. Okay, so yeah, so make sure that you're happy with your addition and subtraction of like positive and negative numbers, okay, and times and dividing as well, okay. So that's the answer for this first section, okay. For that one. Okay, so White Rose Maths answers. Here we go. Okay, there we go. There we go. Okay, so let's learn. Okay, White Rose Maths. Okay, so we've got a function machine, we've got an input, we've got a function, and we've got an output. Okay, so the function here is it adds 10 each time. So if the input is 3 plus 10, the output will be 13. Okay, so the function is adding 10. Okay, so the output, what is turned out here from the other side of the function machine, is positive 13. Okay, there we go, so 13. Okay, what about 60 plus 10? Again, hopefully you're happy with this. That'll be 60 plus 10 will give me 70, guys. Okay, for that, okay. So minus 7.5, so slightly more trickier this time. Okay, so something minus 7.5, and then I get an output. Okay, and then I've got my times 12 there. Okay, I've got minus 8. So these are all the operations, okay, that I can do. So this one here, find the input of the function machine. So something times 6 is 48. So going backwards, the opposite of times by 6 is to divide by 6. So the input will be 48 divided by 6. Okay, I'm going in the opposite direction, so I'm going to do the inverse operation. Okay, think of it here as like an equation. Okay, I've got some number, I can call it x. Okay, x times 6 has to equal to 48. So you would form like a one-step equation here, and then solve it if you're not sure here. So x times 6, okay, has to equal to 48. So you'd obviously have your 6, x equals 48. So divide both sides by 6 to get x on its own. Okay, you'd get that x is equal to 8. Okay, 48 divided by 6 is 8. Okay, so, so the input is equal to 8. So here we go. Okay, so going backwards, we're going to divide by 6 and that. Okay, true or false. So 3 and then something square root actually gives us 9. So here, so square root of 3 actually doesn't actually give me 9. Okay, so this is actually false. Okay, it should be 3 and then you square it. Yeah, so the actual one, the correct notation should be like a little, like a subscript, and then it should say like a 2 here, or it should say like squared, okay, or raised to the power of 2, in any way, shape or form. Okay, but that symbol means square root. Okay, square root is the opposite of squaring. Okay, square root of a number makes it smaller rather than bigger. Okay, so 3 squared is 9. Okay, and the square root of 9 is 3. Okay, and the square root of 9, I'm taking that to be like the positive square root of 9, which gives me 3. Okay, so the answer is false, guys. Okay, so the answer is false. Okay. So opposite is squared. Okay. So here we go. Yes. So this time that is actually correct. Yes. So the square root of 81 is 9. Yep. Okay. So that is actually correct there. Okay. So that one is correct. Yes. Okay. So yeah, I'll just delete that now. So this example, to be clear, so this one's actually true. Okay, this one here. Okay. Find the outputs of the function machines. 6b times 2, well, that will give me 12b. Okay. The next one, 6b divided by 2 is going to be 3b. Okay, I'm halving it. Okay. The last one, 6b, and then I add 2, well, that will just give me 6b plus 2, okay? The input is an expression, and by applying like a number to it, the output will also be an expression, okay? Yeah, because b can obviously take any value, okay? So your output will always still be an expression, okay, if your input is an expression, and if the process, involves like a numerical step, okay, if that makes sense. Okay, 12b, 3b, and 6b plus 2, okay, or 2 plus 6b, again, either way around you do it, it will give you the same, like, expression, okay, as long as we are consistent with our, signs. Find the output of the function machine. So 4x plus 10, that's all divided by 2. So I do 4x divided by 2, that will give me 2x. I would then do 10 divided by 2, and that will give me positive 5. So your final answer is 2x plus 5, or 5 plus 2x. Okay, either way is fine. Okay, either convention is fine and appropriate. Okay, for the examiner. Okay, as long as we are consistent with our sign or our signage. Okay, so remember that everything is divided by 2, okay, and not just the 4x or the 10. Okay, the whole thing is divided by 2. Okay, this next one, find the input of the function machine. So something times 3 and I get 12w plus 9. So going backwards, I'm going to divide by 3 because that's the opposite operation. Okay, that's the inverse operation. So 12w plus 9, okay, all divided by 3. Okay, so I'm going to write it as like a fraction just to make it clear. So dividing all that by 3, well, 12w divided by 3 is going to be 4w, okay, and then 9 divided by 3 is going to just be 3, okay, positive 9 divided by 3 is going to be positive 3. So your input is 4w plus 3, or 3 plus 4w, okay, either convention is appropriate and will suffice for the examiner. Okay, so times by 3, okay. So again, going backwards, divide. This next one, find the outputs of the function machines. So 5y and I square it. So squaring 5y, so it's going to be 5y times 5y, which is going to be 25y squared. Okay, I square the 5 and I square the y, so it's 25y 5y squared. Okay, it's not 5y squared or it's not 25y. I'm squaring the whole expression here. So I'm squaring everything inside this bracket. Okay, so yeah, it's going to be 5y times 5y. Okay, this next one, y minus 5 all squared. Well, that, yeah, I can write it as, yeah, y minus 5 all squared. Okay, or I can, yeah, I can actually expand here. So yeah, either in, yeah, factorized form here or expand form here is going to give you the same answer. So if you expand that here just out of interest and curiosity, you will get y squared minus 10y plus 25. Okay, or I can write it as y minus 5 times y minus 5. Okay, as long as it obviously factorizes here to make y minus 5 here all squared, then your answer will be okay. Okay, this last one, 5y minus 2. Again, I'm going to square everything. So 5y minus 2 all squared. Okay, the reason why here I'm not actually expanding it here because it doesn't actually say so. Okay, it's just obviously like squaring it here. Okay, yeah, I'm essentially trying to obviously avoid doing like extra actually work here because it's not actually asking me to actually write out the expanded version. So technically for this first one, I could have actually written as 5y all squared. Okay, but because that one, it didn't need like a lot of work actually worked out here. So I thought, there was no harm in, obviously ran out the actual expanded version. But again, please feel free to obviously write out the expanded version. If you expand this last one and you simplify it fully, you get 25y squared subtract 20y plus 4. Okay, or you can write it as 5y minus 2 times 5y minus 2. Okay, either way will give you the same answer. Okay, here we go. Okay, they obviously expanded here, which is fine. Okay, which is that fine. Okay, yeah, so equivalent here. So either what answer will suffice. This next one, so find the input of the function machine. So something and I square it and I get 64w squared. So the opposite will be to square root. Okay, so square root of all this. Okay, well the square root of 64 is going to be 8 because 8 8s are 64. 8 times 8 is 64, or 8 squared is 64, or 8 to the power of 2 is 64. And the square root of w squared here is just going to equal to w. Okay, for that, okay, because w times w is w squared, or w multiplied by w is w squared. Okay, and if you square all this, you will get 64w squared. Okay, you'll get 8 squared, which is going to be 64, times by w all squared here, which is just going to equal to w squared. Okay, this next one, okay, yeah, I've got to obviously work backwards here, so I've got to obviously do out the root here. Now here, it's a bit more trickier. So if I factorize this first of all, okay, that will factorize into x minus 3 times x minus 3. Okay, the x and x make the x squared. Two numbers that add to make minus 6 and the same two numbers that multiply to make positive 9. Well, that would be negative 3 and negative 3 because negative 3 add negative 3 is negative 6. Okay, and negative 3 times negative 3 is positive 9. Okay, so I can write that as x minus 3 all squared. Okay, and being very actually careful here. So if I take the square root of this, or this here, it's just actually gonna actually leave me here with just x minus 3. Okay, because the square root and square are essentially what we call like inverse operations. Okay. If you square root like something squared, then the square and the square root, they just actually cancel out here one like another. Okay, it's the same idea as like taking like a number like 4 and then timesing it by 2 and then dividing it again by 2. Okay, yeah, it is going to give you the exact same answer that you had actually that you had right at the start, because the times and the divide are what we call inverse operations. Okay, yeah, so think of it like that. Okay, in this context. Okay, So the opposite of squaring is square root. Yeah, and if you take the square root of something squared, then yeah, it's just obviously that's something that is actually left in the end, okay? Because the square and the square root cancel each other out, so they like knock each other out actually. Okay, so answers for these: square root w. Okay, factorizing that, we get x minus. Okay, this one. So 8 plus 3 is 11, and then 11 times 6, so the output is going to be 66. Okay. For that. Okay, so this is what I call like a two-step function machine. Okay, this next one, I'm going to do 8 times 6, which is going to be 48, and then I'm going to add the 3, and I'm going to get 51. Okay, that's your answer to this one there. Okay, what's the same and what's different? Well, the operations here are actually different. What's the same as here? So I've got like the same starting number. Yeah, so I start actually. What's different is that is that I'm doing like different operations here, because adding 3 and then times by 6 is not the same as times by 6 and then adding 3. Okay, okay. So be very actually careful there. Okay, so same start number. What's different is obviously times and adding different numbers. Okay, 11 times 6 is going to be 66. Okay. 8 6 is going to be 48. 8 times 6 is 48. Plus the 3, and I get 51. Okay, there we go. Okay, this next one, find the outputs of the function machines. 3c times 4 is going to be 12c, and then add on the 2 to 12c, and I get 12c plus 2. Okay, or 2 plus 12c. Okay, either answer will suffice for the examiner. This next one, 3c plus 2. Okay, here I've got to obviously be careful here. So all of this is being times by 4. Okay, so I can write it out like a little bracket. So I'm going to have 4 lots of 3c plus 2. Okay, because I would do what's inside the bracket first if I was to follow BIDMAS or BODMAS, and then I would times by 4. Okay, so either that, or if you expand it, you get 12c plus 8. Okay, if you expand that single bracket, 4 times 3c is going to be 12c, and then 4 times positive 2 gives me positive 8. Okay, and again, I can have it as 8 plus 12c. Okay, or any other form. Okay, for that one. Okay, or 4 lots, so 2 plus 3c in brackets. Okay, brackets closed. There we go. Times 4. Okay, there we go, and then it gives you 12c plus 8. Okay. This next one, so find the output of the function machines. So a minus 1 plus 2, well, minus 1 plus 2 goes to positive 1, so I'm going to have a plus 1. Okay, when I collect my like terms, okay, so here I'm doing negative 1 plus 2 is going to be positive 1, and I'm going to multiply all this by 5. Yeah, so it is going to be 5 lots of a plus 1. Okay, remember that a bracket means that I'm doing some timesing. Okay, remember I'm obviously actually following like BIDMAS here. Okay, so I do what's inside the bracket first, and then I multiply by 5. Okay, in this case. Okay, so avoid writing it like this, because that will obviously open up that problems with like BIDMAS. Okay, because here if I like that's using BIDMAS, then you would you'd actually have a plus 5 rather than 5 lots of a plus 1. Okay, so be very careful. So where possible, put some brackets there. So introduce some brackets to actually make it clear that I'm doing that. Okay, this next one, a subtract 1 plus 2, well, that'll give me a plus 1, And then the next part, yeah, I'm dividing by 5. So the whole thing here is divided by 5. So I'm going to write it as a fraction. Okay, so a plus 1 all divided by 5. Okay, yeah, so it is not a over 5 here plus 1 or a plus 1/5 or a plus 1 over 5. The whole thing is being divided by 5. Okay, I add 1 first and then I divide by 5. Okay, remember, yeah, that a fraction just means a division. Okay. Okay, I could, yeah, write like this, yeah, but yeah, I'll try to see what it is. Yeah, so this is like another way of obviously writing it. So technically, yeah, that would also suffice. Okay, but at this stage, yeah, obviously, yeah, like, yeah, we obviously, yeah, avoid it write like a division, yeah, and write like a fraction instead. Okay, for these questions. Okay. Okay, so answers for these. There we go. Times sign. Okay. 1 divided by 5. Okay. Find the input of the function machines. Okay, so this time, yeah, I've obviously got to work backwards. So the first step is I'm going to divide by 2 and then I'm going to subtract 3. So do it one step at a time. Okay, yeah, so take your time, guys. Yeah, so do everything one step at a time. So 4x plus 14, actually, divide that by 2. I'm going to get 2x plus 7. Okay, because 4x divided by 2 is going to be 2x, and then 14 divided by 2 is going to be 7. I'm now going to subtract 3. Okay, so my final answer will be 2x plus 4. Okay, because 7 take away 3. Okay, yeah, so collecting my like terms, so collecting my number terms. Okay, I have 2x plus 7 minus 3. Okay, when you simplify that, yeah, so that will give me positive 4. Okay, and the 2x here obviously just stays the same. Okay, and again, I can write it as 4 plus 2x, or 2x plus 4. Okay, that will obviously suffice. So going backwards, divide by 2 and then subtract 3, you get that, and then you get that. Okay, so this one here, so complete the function machine. So I've got k something, and then something, and then get 3k plus 5. Okay, so taking our time here. So first of all, yeah, it's been times by 3 first. Okay, yeah, so I times it by 3 first, and then I add the 5. Okay, because remember 3k means 3 times k. So 3k, remember, means 3 times k, or k times 3. Okay. Remember, in algebra, we don't obviously write this with times in here as there. Okay, so k times 3, or k lots of 3, or 3 lots of k. Okay, once I've done that part, then I'm going to add the 5 to make the 3k plus 5. Okay, yeah, because if I do it this time, k times 3 gives me 3k, and then add the 5, which is the next step, I get 3k plus 5. Okay, or even 5 plus 3k. Okay, either answer would suffice for the examiner or the marker. Okay, for that. Okay, so you're always looking at what step has been done first. Okay, and unraveling, yeah, and obviously working backwards. So yeah, the last thing that was obviously done here was added 5. So yeah, if you go backwards here, so you'd obviously minus 5, and then you would then actually divide by 3. Okay, and then from there you can obviously work backwards here from the inverse to see what your opposite would be. Okay, so the last thing that was applied to the expression was add 5. So I would subtract 5, I'd get 3k, and then I would divide by 3 to get back to k. There we go. Okay, this last one. Okay, so pause the video, guys, here, and have a go at this question. Okay, so okay, so let tell me the function machine like this. Okay, so yeah, so we'll come to that in a second. Okay, so the last thing here is I've added 7, so I'm going to subtract 7 here if I'm working backwards. So going this way, yeah, it's going to be a minus 7. The opposite of minus 7 is going to be plus 7, so plus 7 is going to go there. When I subtract 7, I get back to 4r. 4r divided by 4 gets me r, okay, because remember, yeah, 4r means 4 times r. So the opposite of division is a multiplication, so it'd be times by 4. Okay, r times 4 is 4r, and then add the 7 and I get 4r plus 7, or 7 plus 4r. Okay, either expression means the exact same thing, and the examiners here will obviously give you the same marks, okay, for this. Okay, so this is actually wrong, actually, yeah, so this is actually wrong, okay, so why might Tommy have made a mistake, actually? Because if I do this here, so I get r plus 7, and then that's all multiplied by 4, okay. Now if you do that, and you expand here this single bracket, remember, so you have 4 lots of r plus 7. If you expand this single bracket, you do get 4r, however, you also get 4 lots of 7, which goes to 28. So this way here gives you 4r plus 28, or 28 plus 4r, and that's not the same as 7 plus 4r, okay, that's not the same as 7 plus 4r, okay, yeah, because obviously 7 does not obviously equal to 28, okay. 7, yeah, is a factor of 28, and 28 is a multiple of 7. However, yeah, doing it this way, remember, if I add first and then I times, okay, I'm essentially obviously using BIDMAS, okay, I'm essentially doing like a single bracket here, okay, you would add 7 first using BIDMAS or BODMAS, and then you would multiply by 4, okay, so that's where the mistake actually is actually made here. Okay, whereas it should have been you times by 4 first and then add 7. Okay, remember that times it by 4 and then adding 7 is not the same as adding 7 and then times it by 4. Okay.